All right. Well, good morning, everyone. Welcome to breakout session number 3 on augmented and virtual reality for manual workers. I'm Hillary Parker, and I'm part of the CAMPS program committee, and I'll be moderating today's session. I'm a shareholder at Clark Nuber, and we're a locally owned CPA consulting firm, and we work with middle market companies such as those in attendance today. If you haven't had a chance, please check out our booth to learn more about us, as well as the other virtual vendors. A few logistics before we introduce this morning's speaker. This session goes until 11:35. At that point, we'll break for lunch and resume at 12:05 with a panel on Industry 4.0, so don't miss that. And as we move through the session this morning, please ask questions in the chat. We have a lot to cover today, but we'll monitor the questions and try to get them all answered. The session is being recorded, so if you missed anything, you will be able to access it later. And at the bottom of the screen, you'll get a feedback form. There's a button for you to click on that. So if there are any questions that don't get answered or you don't want to ask them here publicly, you can leave your contact information in that form and we'll make sure to follow up afterwards. Please be sure to leave your contact information, though, if you do want to follow up, because otherwise the feedback form is anonymous. And with that, I'd like to introduce our speaker, Zeeshan Zia. Zeeshan is the co-founder of Retrocausal, which builds computer vision solutions to understand human activities on the manufacturing floor. Before starting Retrocausal, Zeeshan was leading a team of scientists at Microsoft's Hololens division, working on augmented reality for frontline workers. Before founding Retrocausal, Zeeshan also worked as a research scientist, which included working on MSR AI and mixed reality for Microsoft. He holds a PhD in computer vision and taught robotics. So please join me in welcoming Zeeshan.
Hi, everyone. Thanks a lot for joining. Let me share my screen real quick. And thanks, Hillary, for that introduction. Really appreciate your time. And let me share I hope I'll assume that you can see my screen. If you can't, please tell me. So I'll get started right away. What I'll focus on today is digital work instructions, and I'll talk about augmented reality in that context as well. So the general problem is, we all know about paper-based work instructions. If you go to any manufacturing floor, you'll find printed papers that tell an associate how to do their job. You'll find on these paper work instructions sometimes pictures, sometimes text that is telling the worker which steps they are supposed to perform and how they're supposed to perform it. In high mix assembly situations or build to order manufacturing situations where a lot of different SKUs, a lot of different products have to be assembled at the same workstation, these can get very unwieldy really quickly. Secondly, there's no real way to enforce that the associate is actually following the work instructions. Another challenge is that you don't really measure anything from these work instructions. You don't really measure how much time individuals are taking to perform their jobs, how many mistakes they're making, and so on and so forth. So there's no way of using paper-based work instructions to improve your processes or to reduce quality-related issues. So that is where digital work instructions come in. But in the space of digital work instructions, people have so far just tried to digitize what you could see on paper anyways. You'll see PDFs, you'll see PowerPoint-like experiences where you don't really utilize the strengths of the digital medium. You could be building you could have built these kinds of digital work instructions that we are seeing on the factory floor often today, 30 years ago, right? So what I'll focus on today is what we call interactive digital work instructions. And I like to take the example of, I like to analogize it with what has happened in advertising, for instance, right? If you look at when television was with every platform shift in advertising, new technologies came in, but at the beginning, the advertisers were using these technologies in the way that they were using them for the previous paradigm. So for instance, when television was introduced, the first advertisements on television were still done the way ads were done on radio, or the way ads were done in newspapers as posters, right? So somebody will be sitting there on the television screen and reading out uh, the benefits of a product, right? Instead of actually acting it out, they were still following how you did ads on radio, or they will put a big poster, a banner on the TV and tell you the benefits of a product. So they were just following how newspaper advertising worked, right? And it took a while until they realized that television had its own unique strengths, and until they actually started acting out, right? Visually acting out benefits of a product. And that's how television advertising really became important. Similarly, when the next paradigm shift happened, when internet came about, right? You had Yahoo and other websites in the beginning of the internet, in Internet 1.0, where you would still see these banner ads like you see them on the in newspapers, and they were being broadcast to everyone, right? And it took a while before they realized that, hey, you know what, we can target individuals much better and show them relevant ads, right? So similarly, what we have seen is that work instructions, even though they have been ported to the digital realm, they're not really utilizing all the strengths of the digital realm. And that's primarily what I'll talk about today. How can we make digital work instructions more interactive? And specifically, I'll talk about 5 different ways, 5 different solutions that exist in the market today to make digital work instructions more interactive and really distinguish them, get a lot more out of them as compared to paper work instructions. So just quickly going over some of the problems generally facing manufacturers is that even large sophisticated manufacturers that we are working with are losing up to 20% of sales revenues annually to quality issues. And there are several reasons for that. And about 68% of these revenues are caused by human mistakes. Of these lost revenues are due to human mistakes. And there are several reasons for it. One is that experienced workers are retiring. They are taking away a lot of their tribal knowledge with them. Temporary workers are on the rise. In US manufacturing, temporary workers have more than tripled over the last decade, right? And they stick around for about 3 months on average. So how do they tend to make more mistakes. They are less well-trained. They're less motivated. Another challenge with large and small manufacturers is that they're having to introduce new processes all the time. We work a lot with automotive manufacturers. And what we find is that they're having to introduce, because of electrification, self-driving, new powertrain technologies, they're having to change their processes all the time. And when you change processes, even if you have the best workers on the planet, they'll tend to make more mistakes because your process itself is not very optimal. Finally, a lot of manufacturers in the Washington area anyways tend to do build to order style manufacturing or high mix manufacturing. But even in the Midwest, even elsewhere, large manufacturers, due to changes in consumer behavior demands, are also having to move towards high mix assembly or build to order assembly, more or less. So there are more products coming down the same line. Workers are not doing very repetitive tasks, which means that they tend to make more mistakes. And again, this digital work instructions become more important, right? On the left-hand side, you see a cartoon of a large assembly line. You have some workstations. Workers are doing their jobs. They tend to make mistakes. You have quality control at the very end of the line. Might be a machine vision system. It might be humans. And you hope that all of the mistakes were caught, but you have to send that product to a rework line, or you have to scrap some of your product, right? And similarly, even if you catch some of the, if you can't catch some of those mistakes, you might have recall costs in the future, right? So what I'll talk about is using work instructions in a more interactive way, so that you can do human-centric quality control and analytics that maximize yield, reduce mistakes, and so on and so forth, right? So these systems will help you do worker training in a more data-driven way, You'll be able to do quality control in a more continuous manner. You'll get more visibility into new processes, and you'll be able to improve your processes a lot faster. And so basically what I'm going to do today is I'm just going to walk you through 5 different kinds of solutions that exist today in the market for interactive digital work instructions, right? For making work instructions more interactive, getting more out of them. These are from 5 different vendors, but I'm happy to point out, alternative vendors for these as well. We are Retrocausal and we build computer vision for process understanding. But again, I'm happy to point out alternative vendors to similar technology, right? But my objective today is to just give you an overview, give you a detailed survey of everything that exists in the market to make your workers more efficient by digitizing work instructions. And by and large, what I'm going to do is I'm going to just show you a bunch of case studies, show you some demo videos, right? Some of them will have narration in them. So you'll just be able to hear these videos. And again, feel free to ask me any questions in the middle, stop me in the middle. I can shed more light on these solutions. I'll also try to talk about the pros and cons of each of these solutions. So let's start with head-mounted augmented reality. Right. I used to work at Microsoft. I used to lead a team that built the HoloLens. I don't know if you know what the HoloLens is. It's a head-mounted display device. It's got a bunch of cameras on it. You can see things overlaid onto the real scene on the HoloLens. And you can, and the system understands what the worker is doing as well. I'll just show you a couple of videos on how the HoloLens is being used on the floor, on the factory floors, and we can, and then I can talk about pros and cons of HoloLens. So this is Satya Nadella. Let's look at a video of his. It's just 2 minutes. He'll talk about a use case on the Toyota factory floor for worker training.
And they're using new tools like Dynamics 365 guides to.
So this is something that actually me and my team, while we were at HoloLens, were able to deploy. So this is very close to me.
They're using new tools like Dynamics 365 guides to access step-by-step instructions on the job and quickly get up to speed. Earlier this year, I virtually visited a Toyota plant in Indiana and met Natalie Strobel, who started on the assembly line and is now a trainer in the plant. She's been using Dynamics 365 guides to help skill a new generation of workers. Let's take a look.
The 4T Academy launched in the fall of 2020. We partnered with 3 local schools to help students learn job skills. We have a skills gap in the area, and to work here, a lot of skill is required. Part of their internship is going to be building vehicles on the line. And so to prepare them, we train them with the HoloLens. With the HoloLens, they can see holographs at the same time that they're seeing the door to show them where to safely put their hands in the door or how to hold the wire or the correct orientation of that part. We're able to show them all of this information more efficiently, quicker. And so I feel like they're able to feel part of the team sooner. When I create a guide or offer it, I'll use the HoloLens and move my holographs around. I can change the shape of them, I can change the color, move them in different locations, and then if I want to make changes to my instructions, I just lean over to the laptop and I type in my instruction, and it's all working at the same time, which makes it so efficient and so easy to use. One of the most exciting things with the 4T Academy is that these students will get to stay in their own communities. And
so that was an example of how HoloLens is being used for worker training. You saw that that a trainer who was she wasn't a professional engineer by any means, and she was able to set up these HoloLens experiences to help these workers train, to show them interactive work instruction, to show them work instructions, but that understood what the worker was doing. So when the worker moved to the next step of a process, the system could see that, and it could advance to the next step of the process and tell them that whether they were doing the job correctly or not. Let's look at another example. And again, feel free to stop me in the middle and ask questions if you have any. is an experience that Fujitsu deployed at their networking hardware manufacturing facility in the US, right? So Fujitsu manufactures these electronic equipment in the US, and you'll see how that is able to help the workers understand which steps they're doing, how they're supposed to move forward, and so on and so forth.
Show left. Move down. Move down.
And what you're seeing in this experience is that this is an experience where there's a lot of there are several configurations that this manufacturer offers their customers. So the system is able to
Show
actually
finished.
track those SKUs
Show left.
that the worker is supposed to be building and guide
Hide.
them to help them avoid mistakes. That's the HoloLens. On the advantages front, this is a computer that's compact, that's right there on
And
your
they're
head,
using new tools.
right? It's somewhat lightweight, but you can just take it into small corners. If you are assembling an airplane and you need to be in a small part of the fuselage, you can take the whole digital work instructions with you in there, because again, this is like a small helmet on your head or a small, well, slightly bigger pair of glasses on your head. That's a great advantage of this. Another advantage is that it's really understanding. There's a camera on it, and it understands where your hands are, so it can offer you very interactive instructions. It understands which step of the process you're at, provide those kinds of guidances. On the flip side, these are relatively expensive devices. Today, they cost about $5,000 a pop. Number two, building these experiences can be very involved. So the experience that you saw for the Toyota factory, for that trainer, it takes her, she needs to be trained on the HoloLens, and then it takes her further weeks to build the kinds of experiences that you were seeing here. The Fujitsu example, on the other hand, literally this is something that took them half a year to 3 quarters to build this experience. So to be able to use the HoloLens, you not only have to buy the HoloLens, you actually have to build these experiences that model your individual workstations, and they can take a lot of time, right? That's one issue with the HoloLens. Obviously, then there are others that are usual to head-mounted display devices. You can have nausea. Sometimes you don't want to have that big bulky device on your head all day long. But that was the HoloLens, right? That's a new way of incorporating work instructions right there in the worker's field of view. Personally, I think that as the HoloLens gets smaller and smaller, or as new head-mounted display devices get introduced, maybe next year Apple is introducing one, this is going to become more and more a norm for workers to get instructions from these kinds of experiences. Let me move on to the second kind of solution that provides you very smart interactive work instructions. And this is what is known as Projector augmented reality. So augmented reality based on a projector system, but that also has a camera which understands which step of the activity you're at currently. So let's look at some demo videos for this sort of a solution.
Light Guide Systems is the
Specifically,
ideal
I'm showing you some examples from a vendor called Light Guide Systems.
visual guidance solution for automotive interior assemblies such as headliners, door liners, and center stack or IP clusters. In this demonstration, a headliner is assembled by two people working independently and asynchronously. The first step in the process is to inspect felt components, with the light guide system using a 3D sensor to confirm the inspection of each component and auto-advancing the work instructions until all inspections are completed. The process continues with the first operator laying down glue for foam block placement and the second operator beginning the harness installation, again working independently. Once the gluing is completed, the foam blocks are ready to be placed following the visual guidance, and once the last block is in place, Light Guide Systems again auto-advances via 3D sensor confirmation. Now, both operators work together to complete the harness installation and taping process. Visual guidance indicates where the tape is to be placed. The work is self-paced until completed. The second operator moves away to prepare for the next headliner build, while the first operator works until the harness taping is complete. When done, he touches the soft button to complete the build process.
So this was one experience. Let's look at another experience, and then I'll talk about the pros and cons, the strengths and weaknesses of these kinds of solutions.
Light Guide Systems.
We know that vendors such as Packard, right in our backyard, the auto, commercial vehicles giant, as well as companies such as Whirlpool are using light guide systems to train their workers. Unfortunately, I haven't seen any examples of these systems being used in real deployment after training, but the objective is that you get a temporary worker on the factory floor, and within 20 minutes, he or she is able to be productive without requiring somebody to train them manually, right? They go to one of these training stations and they can understand how this process is supposed to be performed, and they get productive right away. Let's look at another example. So this is projector-based augmented reality. And there is a camera that is understanding every step of the process that the worker is making. Here you are seeing that the system is able to track individual steps of the process. It's measuring the amount of time being spent on these steps. Obviously, the setup is slightly contrived. It's not really a real assembly line, but for worker training, this is pretty good. And I know several deployments that they've had, where workers are being trained in this way. So again, these are very smart worker instructions, right? The worker is seeing what they're supposed to do. The system at the same time is measuring the amount of time that the worker is spending on these steps, right? The quality of these processes and so on and so forth. Again, as compared to just having a PDF on a screen or a list of steps on a screen, right? This is much more than that, right? The system actually understands how you're doing the process, right? It can actually give you feedback on the quality of your work. And the timing metrics that you're seeing here, they can appear later on a dashboard, let's say on a lean engineer, industrial engineer's dashboard. If the workers tend to make mistakes, they can appear on a quality engineer's dashboard, so they can improve the process as well. So apart from helping the associate, these systems are also helping the industrial engineer. They're also helping the quality engineer. So now the worker is assembling the wire harness. This is a relatively simple wire harness, but you'll see, I can show you much more complicated examples of wire harnesses being done with light guides guidance, essentially. I think it's a really good tool for wire harnesses especially. Obviously, I'm happy to share some of these links with you. You see that the system was able to understand these steps. One challenge though here is that for several of these steps, the system, for some of these steps, the system does understand which step you're at. For some steps, the system does not. So you are seeing that forward button, right? Where the worker has to tell the system to advance to the next stage. And this can throttle the worker's ability, right? This can slow the worker down. So that's the flip side of being too interactive, right? If you are asking the worker to tell you to do, to basically talk to your system all the time, that may slow them down sometimes. So there is this flip side to it. So again, just quickly going over the pros and cons of this sort of a system. On the pro side, right, this is a very smart way of doing work instructions. If you have a lot of temporary workers, you can train them through these sorts of systems, right? You can build a bay, a training workstation, dedicated training workstation. An associate goes there, or on your live workstation, you can set up this system. So you set it up, you turn it on when a new worker comes in, and in 20 minutes, they are able to understand what they're doing and basically become productive, right? Another use case is, I haven't seen a lot of those examples, but in the high mix assembly situation, where workers are prone to making more mistakes, if they have, let's say, 100 SKUs, you might be able to connect these kinds of systems to a manufacturing execution system. So it fetches the current build order, and the worker is able to understand which steps of the activity they're supposed to be doing. Let me see if just quickly, if there are any questions or comments or chat. Okay, fantastic. I'll move on to the next solution, the third solution that I wanted to talk about. And again, feel free to stop me in the middle. Happy to take questions anywhere. Another kind of solution that you'll see in the market right now is what I like to call interactive PowerPoints, right? Where it's sort of the work instructions are in the form of, let's call it PowerPoint presentation, but where the worker can tell the system what he or she is doing, and the system can also understand, fetch data from different sensors, again, to check for quality, to understand what's going on, and so on and so forth. Let's look at one of these systems from Tulip. This system, the video quality is not that great. This video is slightly older. This company has gone on to raise a bunch of money from venture capitalists, and you will see a lot of great videos on their website. I just like this particular video because it's a little bit clearer in what the system is able to do, what the platform is able to do. So this is a video from when this company was incubated at MIT, right? It's been 4 years since then. They've raised a ton of money. They've done a ton of deployments, but this video will show you what it is that what their core competence is, right? And obviously I can talk about alternatives to this sort of a solution as well. They're competitive.
This is a little demonstration of what we're doing. So what you're seeing here is the first step is connecting devices to our IoT gateway, and you can see one example of the interface here in the form of a touchscreen. This touchscreen is giving you the interactive work instructions that a process engineer might put together. You can see that there's a whole host of devices. So we saw RFID sensors. This is a foot pedal, and here's a barcode. So that, just to give you an idea of a device library. Then here's, here you can see, visual work instructions that are interactive per whatever the sensors are reading from the actual manufacturing bench. And these work instructions can exist on various devices. So here's like a touchscreen, here's a tablet. This is showing an example of a digital form that allows you to collect picture. This is what a quality engineer would usually use. to collect the information, and this is helpful to create defect image galleries and all sorts of other critical information. Of course, all of this lives on mobile, so all the information collected from the floor can be pushed to your smartphone. And here is an example of what we call the profiler and debugger for manufacturing. So this is basically, this is really quick, but this is an example of our analytics builder. So this allows you to very quickly kind of take a process and like break it down to the different pieces that you're interested in here. It's kind of hard to see here, but this is like the timing, and this is like the steps, and the red is like the tack time view of this. But the idea is that you basically have a profiler and a debugger for manufacturing that tells you what each individual operator carried out at a certain point in time. So you can compare, like, here you can see the cycle time is set to roughly 10 seconds, but nobody on the production line can hit it. As opposed to, probably some people here found a way to do something faster, which may suggest you need to change your process. So that level of granularity is really important when you're trying to get a manufacturing process really tuned to be the best that it can be. And of course, labor, we didn't really discuss it, but labor is such a big component of the cost in manufacturing, so it really comes down to the bottom line. Because it's such a big, complex system, like it's not like, okay, let me show you the app and this is what it's doing, input, output, whatever. It's more like, talking about something like the size of a sales force. So how do you describe that? You need to describe like all the different bits and pieces of it for it to actually make sense. If I just tell you that it has a contact book, you're like, that's nice. And if it has like a sales process, okay, that's interesting. But it's only when you connect all the things. So that's why, and in our case, there's actual things. Like it's not just an app on the cloud. So it's hard to fully like take the concept across. But if we if we have like this type of camera set up and lighting for a couple of hours in our space, it would be very easy to like show real world examples, and then you just like shoot it in place, and that's it.
So basically, what this system was, the video emphasized a little bit more on the industrial engineering lean side, right? So what you saw was that, again, this is a very interactive system that can really read in a lot of data from a lot of IoT sensors. You have a vernier calipers, you have a weighing machine, you have a barcode scanner, and so on and so forth. All of these tools can be plugged in to that Tulip hardware, and from there they feed into the device. On the flip side, you need a software engineer to actually set the system up to actually digitize these manual processes. So in that, and you probably need to also modify your process itself. So these are issues. These are the problems with this solution. Your workers might also need to interact with this solution a lot, right? So it is interactive digital work instructions, but it's a little bit on the extreme end, right? You need to tell the system a lot what you're doing. But again, this is an example of a system that might be more relevant to larger manufacturers, where you can have work instructions that actually understand what the worker is doing, not only guide them through the process, but actually understand what they're doing, provide them with feedback, collect data so that later your industrial engineers, your quality engineers can look at that data and improve your processes, right? I'll move on to my fourth solution that I wanted to talk about. This is interactive video documentation, right? So this is a company called DeepHow, and this is a video of them working with Stanley Black & Decker.
As technology continues to rapidly evolve, people are learning in new ways, forgoing printed manuals and PDFs, turning to more engaging resources online. And as long-term employees move towards retirement, it's vital to capture their expertise, their tricks of the trade and know-how, transferring their invaluable skills to the next generations. This is DeepHow, the first AI solution for learning and training skilled trades. While experts perform their individual tasks and processes, DeepHow captures their workflows via a mobile device. Using the latest AI technology, this captured data is extracted and ingested, turning complex workflows into easy-to-follow, step-by-step guidelines. New employees can access critical training information anytime, anywhere from the DeepHow online portal, learning intricate tasks at their own pace without disrupting other workers or interrupting plant operations. Thanks to DeepHow, we're accelerating learning, increasing productivity, and empowering individuals and teams with everything they need for success.
Right. So this was. I want to be respectful of the time, but this was the fourth example of how work instructions are going digital. In this example, again, what they're doing is they are capturing video, but the video is not just static video. It's actually understanding the speech, the instructions that the associate is telling the system, right? That the expert associate is telling the system, and the system transcribes that into text that you can search later, that you can recall with your own words. So you can ask the system, hey, how am I supposed to plug this pipe, right? Or how am I supposed to put on, cover this hard drive or something like this, right? And the system will take you to the right part of the video and show you that experience. Another one advantage of the system is it's very, very simple to set up. Anybody can set it up. On the flip side, it's more on the training side that it's relevant, not that much on real work guidance, right? Which is what we saw with the HoloLens, which is what we saw to a certain extent in the previous, the Tulip solution, right? That they could actually understand what the worker was doing in real time as they were doing it. DeepHow is more suitable for video training, if it makes sense, right? So this was the fourth solution that I wanted to talk about. And now I'll talk about the fifth and last solution, which is our solution, right? What we did at Retrocausal, what we did was we looked at the shortcomings of the solutions that I just mentioned to you, right? Workers often don't want to put on headsets on their head. It causes nausea. It's uncomfortable. Manufacturers often don't want to have to hire software engineers that will be working for months to create these kinds of experiences that you were just seeing. Manufacturers want to do training, but at the same time, they want the same solution to understand what their workers are doing in real time. They want the same solution to double up as a quality control system, as a continuous quality control system. They want the system to, at the same time, help their lean and industrial engineers improve the processes as well. And finally, nobody wants the worker to have to interact with the system a lot, right? You want to minimize the amount of time that the worker has to spend away from actual manufacturing, actual assembly processes, right? You don't want the worker to be clicking on buttons all the time. So these are some of the requirements that we looked at, and that's what helped us arrive at what I'm going to show you next, right? So what we do in our system is we'll set up an ordinary webcam on your workstation. You can do it yourself. The software works on a standard computer. Let's look at a quick demo video. So this is a display that's mounted on a workstation. This example is a little bit contrived, but I'll show you some real deployments as well in a second. This associate is assembling a desktop computer. And on the left-hand side, you are seeing the standard operating procedure that she's following. The worker missed a step, and she was offered an audible and a visual alert to help her fix that step, to help her fix that mistake. In bold, you see the current step of the activity being highlighted, and this is all happening in real time by the system. The system is understanding, the camera-based system understands which step of the activity this worker is at right now. The system is also measuring the amount of time being spent on these steps. Again, notice that the worker doesn't have to tell the system anything. She doesn't have to click on some button. She doesn't have to interact with the screen. The system is just passively monitoring her, right? And she made some more mistakes. And when she needed input, that's when the system offered an audible and visual alert, and the worker was able to basically go back and fix the mistakes that she was making. And this is all those alerts are being provided to the worker through that display that's mounted on the workstation that you saw at the beginning. Again, the system can be set up by anybody. You don't need an engineer to set this system up. But let's look at a demo video. So this is one of our deployments at actually Stanley Black & Decker that I talked about earlier through another product. What you're seeing here is that the system is tracking fairly subtle steps that the worker is making. I'm not sure if in this video the worker is going to make any mistakes, but you see that this artificial intelligence or computer vision system is able to understand which step of the activity the worker is at right now. When I think she makes some mistakes at the very end of the cycle, and we'll look at those alerts at the end of the cycle. But again, the system is able to track these steps. It's able to measure the amount of time being spent on these steps, even though the steps are fairly subtle. Let me just, in the interest of time, let me just forward it all the way to the end. And you'll see that this worker is going to skip these 2 steps, and basically he'll get alerted about those 2 steps. So you see that these 2 steps were missed, and this was the alert, audible and visual alert that was issued to the worker. And again, not only do we help the worker avoid these assembly mistakes, all of the statistics, all of the timing related statistics and mistake related statistics show up on the plant manager's computer. They can log on to a web portal and look at the number of cycles performed in this duration of time, the average cycle time, the cycles that had some errors in them, the cycles that were performed without errors, the amount of time being spent on individual steps. So the industrial engineer can say, hey, this step was not supposed to take this long. How can I make it faster, right? Or how can I balance my line better? It seems like that this cycle time distribution is too wide for my taste, right? Or why are there so many mistakes being made on these steps, right? Within the system, you also get video traceability. So the system actually acts as a YouTube of your assembly lines. As the workers are doing their job, the system records individual cycles, cuts it off, trims it off, and sends it into the cloud so that you can do root cause. Your industrial engineers can do root cause analysis, figure out exactly where workers made certain mistakes, right? And so that can help you improve your processes. If you have, unfortunately, if you have a recall event at some point in time, you can narrow down the scope of that recall event to specific batches that you have to recall if you have this kind of video evidence. So these are some additional capabilities that we provide on top of that work instruction package, right? And then we also have, video-based training. So what I showed you earlier is live task guidance as the worker is doing a job right there on the factory floor. But there is also a package for worker training, which is not that different from what you saw on the Deep How product. But and setup is really simple. Even an associate can set it up. You don't need engineers for this. All you need to do is you record a bunch of cycles of the process, you enter the bill of process, you label about 5 cycles at the level of individual steps. So you tell the system that on this process, the worker is picking up the chip from the 0th second to the 5th second. He is placing the chip on the motherboard from the 5th second to the 7th second, and so on and so forth. So which takes about 10 minutes, right? And then basically you're able to deploy, right? So setup is really, really simple, but that's really about it. So I talked about, in summary, about 5 different solutions that exist in the market today. And obviously I can talk about alternative vendors to each of these classes of solutions. But this is where what we are seeing with very sophisticated manufacturers. This is where the worker guidance, work instructions world is moving towards. And this is where I think every manufacturer, this is where you're going to be at. You will not have paper-based instructions, rather you'll have some maybe combination of some of these solutions. I talked about the pros and cons of some of these, but yeah, I'm happy to take questions at this point if there are any. I know we might be a little bit over time at this point.
Thank you so much, Zeeshan. I know that most people in attendance here have most likely struggled with training, and these 5 solutions were very interesting case studies for everybody to consider, and no doubt relevant to everybody in the future, as you stated. And I want to thank you again for coming to participate in the conference today. If anybody does have any questions, again, at the bottom of the screen here, you can click on the feedback form, leave your contact information, and we'll make sure to get follow-up to you. We're going to be breaking here for about 30 minutes, and we're going to be returning at 12:05 for this afternoon's panel on Industry 4.0. Please don't miss that. And then we have another speed networking session following that panel to close out afterwards. So thank you so much again, Zeeshan, and we'll look forward to seeing everybody on the next session.
Thanks, Hillary. Thanks, Stacy. Have a great day.
Thank you both.
See you folks
Great
on
job.
other sessions. Bye-bye.
You good?
Yep, good job. Okay.
How was the attendance on some of the other ones?
Kirk said that his was